Show that the roots of x cubed minus x squared plus x minus 1 equals 0 are also roots of x to the 16th minus 7x to the 12th plus 6x to the 8th plus 2x to the 4th minus 2 equals 0. How I do it? Obviously, 1 is the root of x cubed minus x squared plus x minus 1 equals 0, because if we plug in 1 on the left side, we get 1 minus 1 plus 1 minus 1. So let's go ahead and divide this polynomial by x minus 1. Since 1 is a root, notice I changed the sign from 1 to minus 1. So we're going to use long division. So I ask myself, how many times does x go into x cubed? Well, x goes into x cubed x squared times. So we write x squared here, up on top, and then we multiply x minus 1 by x squared and get x cubed minus x squared. Then we subtract x cubed minus x squared from the dividend and get x minus 1. Then I ask myself, how many times does x go into x? Well, x goes into x 1 time. Then we multiply x minus 1 by 1 and get x minus 1. So we're finished with the division. So x cubed minus x squared plus x minus 1 divided by x minus 1 is x squared plus 1. Well, what are the roots of x squared plus 1? What are the zeros of x squared plus 1? Obviously, the zeros are plus or minus I, because I squared is negative 1, and negative I squared is also negative 1. So the roots of x cubed minus x squared plus x minus 1 are 1 and plus or minus I. Obviously, 1 is the root of x to the 16th plus 7x to the 12th plus 6x to the 8th plus 2x to the 4th minus 2 equals 0. Because if we plug in 1 on the left side, we get 1 minus 7, which is negative 6, plus 6, which is 0, plus 2, which is 2, minus 2, which is 0. Clearly, plus or minus I are also roots, because I to the 4th and negative I to the 4th are 1, and 4 goes into 16, 12, 8, and 4. So, since 4 goes into each of these powers evenly, if we're plugging in I, then x to the 16th is going to be 1, and the same for x to the 12th, x to the 8th, x to the 4, and the same goes for plugging in negative I.